In lesson 7.2, we're going to continue solving linear systems, but this time we're going to try the algebraic method for solving these linear systems. You can still check them with the graph solution, however you will have to show the algebraic method that you use to solve the linear system. So for the first method we're going to use is substitution. So you can freeze and look at these steps or go back to these steps after you watch how I will do this first example. So the first example for substitution method, we have two linear equations, and we need to solve them to see what their intersecting point would be. So I'm looking at these two equations and I notice that y is isolated. So y is a single variable. So I'm going to choose one of those equations to solve for y. And this time I'm going to solve for y in equation number 1 just because it's the simpler of the two equations. So in order to do that, I'm going to, and we'll see if we can have some room here, and I'll try to change colors to show you each one of the steps. So I'm going to start out with my equation negative x plus y equals 1. So I want to solve for a single y, so I'm going to add x to both sides. This is pretty simple. And I'm going to get the equation that y equals x plus 1. Now with that equation, I can use the second equation now. Remember, they have to be that they're going to solve for both equations. I'm going to use that second equation, and I'm going to substitute that expression for y. So I'm going to go ahead and I'm going to do 2, and oops, sorry about that. It's going to be 2x plus, and I'm going to put in my new y, which is x plus 1. Sorry, I tried to make that plus better and it turned out worse. Plus 1 equals negative 2. So I'm going to combine my terms. I have 3x plus 1 equals negative 2. This is all simple algebra you've done before. Subtract my 1. I get 3x equals negative 3. Divide by 3. I get that my x value is going to be negative 1. Now I know my x value, but now I have to find my y value. So I'm going to go and I'm going to substitute that into the easiest of the two equations. So that would be equation 1 again. To do that, I can substitute it into this first equation here, or I can substitute it into the one that I put into the equation I used for substitution. And the substitution one is actually an easier one because I want to find y. So I'm going to go back to, let's do this one in black. This is going to finish us off here. So I'm going to take my x value and I'm going to substitute that back in to this equation because I want to solve for y. So I'm going to say that y equals, I'm going to put my negative 1 in for my x, plus 1, and now I'm going to simplify, so y equals 0. So my intersecting point, what we were doing in 7.1, would be the point negative 1, 0. And again, now that you know how to use decimals, if you'd like to throw that into the graphing calculator and just see if that is what the solution or the intersecting point would be. But what we're studying in this lesson is that you know how to use the substitution method to find that intersecting point. So moving on to the next example. This time I have a little bit more difficult beginning equations. So I'm looking first to find which equation has a single variable. And equation 2 has a single variable, it just happens to be x. I'm going to do the same method I did in example 1. So I'm going to use the second equation here. Whoops, and I got it into the first equation a little bit. And I'm going to, let me move that down just a little bit so we can see that later. The magic of Mimeo in one place, it can help me out. So I'm going to isolate my x. So to do that, I'm going to add 4y to both sides. I'm going to get that x equals, there's my isolated variable, 4y minus 1. There's my simple equation for substituting. Now I'm going to go, I'll change colors again, let's not use the red, and I'm going to substitute that into my equation 1. So I'm going to say in this column here, 2, and I'm going to substitute that value in. So that's going to be 4y minus 1 plus 2y equals 3. Now I need to do some distributing. So I'm going to go ahead and I'm going to get that 8y minus 2 plus 2y equals 3. I'm going to combine my terms. I'm going to get 6y. I'm going to combine my like terms as well. And so I'm going to get 6y equals negative 3 plus 2 is going to be, oops, I'm sorry, that's not negative 3. That's an equal sign there, isn't it? This isn't equal. That made it worse again. Let's get all those little lines out of there so I can read my own writing here. This was just an equal, so that was a positive 3. So 3 plus 2 is going to equal 5. All right. Oh, and this was a positive 2y. Wow, I can't read my own writing on this. So this is going to be a 10y. I had an 8y and a 2y. I was looking at my negative 2 when I was trying to see there's a perfect example for not taking shortcuts. And let's go ahead and divide. I was trying to fit into my space here and I ended up making mistakes. Luckily I caught them before I went too far. So now I have that y equals 1/2. Now I can go ahead and I can substitute that in. Again, I'll look for the easier equation. So I'm going to go and I'm going to try to solve for y. Neither of my equations were y equal equation, or I'm sorry, I'm going to solve for x. So I'm going to go and I'm going to use this equation because I want to find what x equals. So I'm going to change colors. So you know I'm going to the next step. I'm going to say that x, I want to find out what x equals. Well, x equals 4 times my y, which is 1/2, minus 1. So 4 times 1/2 would be 2. So x equals 2 minus 1. So x equals 1. So my coordinate point would be 1 for the x and 1/2 for y. And this is my solution for my linear system. All right. That was bad, my shortcuts. I hope some of you saw that. We have a couple of you that like to do shortcuts. All right, so this next page was just showing me again, but we can check and see if this is going to work, the 1 and 1/2, by going to our graphing calculator and see if that is correct. So we can always check our solution with the graph. So here is the graph, not as pretty as on the Desmos, but it has graphed both of those equations, the red and the blue. You can see I did some extra that we could do. I put them in slope-intercept form to graph them, but we have some hard y-intercepts to graph perfectly. We have a 1/4 for the blue line as our y-intercept. We have a 1 and 1/2 or 3/2 for our red line, which again makes it difficult to find that precise intersecting point. I also did a quick graph here by substituting 0 in for y, and then I got that x would be 3/2 and y would be 3/2. Again, those are hard to get exact. So using the Desmos, you would be able to find those exact to check your solution after you've used the substitution method to find the solution. So then our last example is going to be, of course, using some real life. So we have some museum admissions, and it's the National Civil Rights Museum in Memphis, Tennessee. It says they collected $1,590 from 321 people admitted to the museum. So the price of each adult is $6, and the people between 4 and 17 years of age pay only the child admission, which is $4. So we need to estimate about how many adults and how many children were admitted each day. So that's going to be the part of our second equation that has two variables in it. So use a verbal model to find the number of adults and children admitted to the museum that day. So our equation 1 is going to be pretty simple. We're just going to identify that the adults plus the children are going to equal the total that they told us was admitted. So that's easy. We're going to use two variables, x plus y. X is going to be the adults, y is going to be the children, and we know that 321 people were admitted. We just can't write 321. Now, to look at the second equation, which is going to be a little bit more difficult equation, we're going to say the number of adults times the price of their admission. Well, I'm going to kind of switch that around because I don't know the number. That's going to be my variable. But I do know that the adult admission was $6. So I'm going to say 6x. So this one's going to talk all about the price. And again, the number of children, and I know the children were 4y, $4 for each child admission. And I do know that the total that they brought in was 1,590. So those are my two equations. Now I'm going to go ahead and I'm going to solve them as a system of equations. So going to the next page, I believe, I'm going to see that I can go ahead and I can use substitution. I'm going to use that first equation. I'm going to solve for y. So I get y equals negative x plus 321. I'm going to then substitute that in for, well, I guess on this page I'm showing you how to graph both of those. So I'm going to graph both of those. And when I graph them, I find their intersecting point. Now, if I was going to, let's see if I have it, I do have a blank page. So I'm going to go ahead and I'm going to write those down and I'm going to solve those instead by my substitution method. So I have my x plus y equals 321. And I have my 6x plus 4y equals my 1,590. So we're going to go ahead and we're going to see that only one of those equations is going, or only one solution is going to be right for that day. We're saying all the different possibilities, but the intersecting point is what actually happened for that day. So I'm going to go ahead and we'll solve for y in this first one. So we would have negative x plus 321 plus. So I'm going to substitute that in, I haven't been changing my colors here, in my next equation. So I'm going to say 6x plus 4 times a negative x plus 321 equals 1,590. Now I'm going to go ahead and simplify that expression. So I get 6x. Positive 4 times negative x is negative 4x. I'm not going to take any shortcuts this time though. Positive 4 times positive 321 equals positive 1,284. And that equals 1,590. Now I can combine my terms. Let's go ahead and get rid of my constant. Maybe doing it this way is going to help a little bit. 6x minus 4x gives me 2x on the side. And my 1,590 minus my 1,284 gives me 306. Divide both sides by 2. x equals, and if I divide 306 by 2, I get 153. Now I can substitute that back in. I'm going to just substitute that back into my, my original sentence up here as my x plus y equals 321. So I have 153 plus y equals 321. So I'm going to subtract my 153. And when I subtract my 153, I get that y equals 168. So my solution would be that there are, go back to my black, 153 adults and 168, whoa, that was bad, 153 adults and 168 children admissions. And that concludes lesson 7.2.